Okay, so 6.3 has one new rule, and this new rule, I want you to see, well, I may have not told you the truth. There's actually two rules, but I'm going to show you them one at a time. The first one is going to be the rule that you've already been familiar with, so it's technically not a new rule, but there is kind of a spin on it, that if it's in fraction form, so I want you to see that there's two different rules here. Here's the top one that we've learned in 6.2, and here's this one, the same rule being applied, but just in a little bit different format. They're saying that if there is a fraction number in parentheses raised to a negative power, that negative power goes to both pieces, and I want you to see that it then becomes this fraction here. And then I want you to see that for us to get that positive power here, we have to flip it both to the numerator. You have to switch them to the opposite of wherever they are, okay? So the a to the negative n was in the numerator, so it had to go down to the denominator. B to the negative n had to go to the top to the numerator for it to become a positive. So we're going to work on applying that rule. The next rule that we want to apply or look at is going to be the rule for a power of 0. So x to the 0 power, or any number to the 0 power, is always 1. So 3 to the 0 power is 1, and 3,000 to the 0 power is 1. And negative 261,432,641 raised to the 0 power is 1. Okay? So I want you to say anything raised to a 0 power, and I'm going to put that one in parentheses because I want you to know that the negative goes with it. Okay? Anything raised to the 0 power is going to be just an answer of 1. So let's look at some examples of both of these two new rules that we have. Remember that I am asking you to put all of your rules on one page so you can come back to them very easily. So your first problem is going to be 2 to the negative 3 power. Okay? For us to find a final answer, it would have to be flipped from the numerator down to the denominator. And so this is the problem we end up having. The exponent became positive when we flip it. And I know that 2 to the 3rd power is the same thing as 2 3 times. And so I know that this answer is going to be 1/8 because I did 2 to the 3rd power and got 8 on the bottom. Okay? Okay, let's look at this one. Okay, here's that new rule that we're learning for this section, the first new rule. It tells you if you have a fraction raised to an exponent, the exponent goes to both pieces. And when we rewrite this, it tells me that I have negative exponents on both of them, and they both need to flip. Okay, so I end up with 3 squared over 2 squared, and then now I just need to use my algebra skills to solve this. So 3 squared is the same thing as 3 times 3, which is 9, and 2 squared is the same thing as 2 times 2, which is 4. If I can simplify, I will, but if I can't, I leave it like this. Now, some of you are already trying to change these into mixed numbers. I told you that we're done with that. That once we finish that unit, when moving forward, we leave it in fraction form, even if it's improper and the top number is bigger. We leave it like this. Oops, sorry. Okay, this problem is going to be 4 to the negative 3rd power times 5 squared. Okay, so this piece is a negative, so it's got to drop to the below to the denominator. So I have 5 squared over 4 to the 3rd. 5 squared is the same thing as 5 times 5, which is 25. And 4 to the 3rd power is the same thing as 4 times 4 times 4. And 4 times 4 is 16. 16 times 4 gives me 64. How did I know I was going to have a fraction answer? Because one of them was a negative exponent. Had to go to the denominator to give me that bottom number. Okay. Four to the 3rd power times 5 to the negative 2 power. I want you to see that they don't have to have parentheses. Remember, they just touch, it means multiply. And so this guy right here is the one that's negative, so it's going to drop down to the denominator. So I have 4 to the 3rd over 5 squared. It becomes positive 2 when it goes to the opposite position where it was. And so this is the same problem that we just did. So 4 to the 3rd power is 4 times 4 times 4, which is 64. And 5 times 5 is 25. And so this is my final answer for this one. If you don't remember, see, 25 over 64 and 64 over 25. It was because this one was negative the first time the 4 was, and then the next time the power of the 5 was exponent was negative. Okay? Okay, a little shortcut. If you know that everything inside parentheses is going to get this negative exponent, it means that everything inside is going to have to flip. And when it does flip, everybody has a positive exponent now. So you can skip this step just a little bit and give it this positive exponent by flipping it over. So then you know that the positive exponent goes to each person for a final answer. How did I get 1 on the bottom? Well, 1 times 1, it tells me what I'm multiplying and how many times I have it. Okay, that's what that 2 is for, how many times I'm multiplying it. So 1 times 1 is how I got 1. And remember, any fraction with a denominator of 1 is just a whole number. Parentheses just mean that we're multiplying, okay? I don't have to leave them in parentheses, and I don't need to because I need to see every piece as an individual. That negative exponent only belongs to the y, okay? How do I know that? Because this is what it would look like if that negative exponent went to both the 4 and the y. The whole grouping would have that power. But since it doesn't, it's only touching this y in this problem, so that's why I know, okay? So every piece is its own piece. The only piece that's a negative needs to go to the denominator. And so when I rewrite this, I have 4 times 5 times y to the 6th over y to the negative, or it's now positive 10. I was going to write a negative, but I shouldn't have. Should be a positive 10. There's a couple of things that I need to do. This is multiplication. 4 times 5 is 20. This is the rule that we learned in our last section in 6.2. So I have y, the bases match. I have my numerator minus my denominator. 6 plus a negative 10, the signs are different. Subtract and take the sign of the bigger number. So I ended up with y to the negative 4th. Why do I know it's in the numerator? Anytime that we do this division problem here, my answer is always in the numerator, okay? This negative 4 is a negative. It needs to go to the denominator. So my final answer is 20 over y to the positive 4. Final answer. Okay, we're going to skip down to a little bit more difficult ones, okay? First one that we're going to do is 4z to the 6th over 3z squared. This whole piece is raised to the negative 3rd power. Okay. Remember how I told you that if everything inside the parentheses is raised to a negative 3rd power, you can flip everything and give this guy on the outside a positive exponent power. And so this is what we now have. I want you to see here that these are all separate pieces. I could put a little dot between them. I wrote them kind of close, but I'll show you that they're separate pieces. So there's 4 pieces, the 3, the z squared, the 4, and the z to the 6th. The 3rd power goes to each of those 4 pieces. So this is what I have. I want you to see here that this is a power to a power, so these get multiplied. So this becomes z to the 6th, and this becomes z to the 18th. 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. 4 times 4 is 16. 16 times 4 gives me 64. All right, so I'm ready to simplify as much as I can. My whole numbers don't simplify, so I'm looking at my bases match. It's a division problem, so I'm going to subtract my exponent numbers. Please remember that I'm going to change this to an addition problem and change the sign of the guy that follows. So this is now 6 plus a negative 18. The signs are different. I'm going to subtract and take the sign of the bigger number, and I end up with a negative 12. Remember that every time I do this problem, the answer is always in the numerator. So now I have this problem here as my answer, 27z to the negative 12 over 64. This is a negative exponent that needs to come to the bottom, and so 27 over 64z to the positive 12th power is my final answer. Okay. All right, I've got one last problem. I have r to the negative 6th power, u to the 3rd power, and m over r to the 4th, u to the negative 5th, and m to the 8th. Okay, I'm going to move this down just a little bit because I want you to be able to see every piece of this. The first step, I'm going to talk about my r's. I have r minus 6 minus 4. It was minus 6 here. I wrote it exactly like it was. This bar right here tells me subtract, and it was a positive 4. When I rewrite this, I end up with negative 6 plus a negative 4. I change it to add and give the sign to change the sign of the guy that follows. So I want you to see now that I have an addition problem where signs are the same. So I will add and keep the sign. So this is gone, and this r to the negative 10 is what I have. Okay, the next piece is this guy here. It's going to challenge your addition and subtraction of sign numbers rules. U3 minus a negative 5. How did I get minus a negative 5? 3's here. This bar right here is the subtraction problem, and it was a negative 5. I'm going to change the sign, and so 3 plus 5, u equals, or u to the 8th power is what I have. Okay. The m's, I have m to the 1st minus 8. M to the 1st plus a negative 8. I'm right, I'm going to change the sign. Signs are different. I'm going to subtract and take the sign of the bigger number, and so m to the negative 7th is what I have. So here's how it goes. I have r to the negative 10, u to the 8th, and m to the negative 7. 2 of these drop to the bottom because they are negative exponents. And so my final answer is u to the 8th over r to the 10th, m to the 7th. Final answer. So make sure you do your TOGO and ask questions when you have them.